Good afternoon, students. So I'm audible and visible to all of you. Okay, where is the mic today? Okay, everybody settled down.
No, ma'am. Half of the people gone to out, ma'am. Break. Shortly they will come, ma'am.
Okay, I'll wait for 3-4 more minutes.
Of course. Come fast, students.
So how many of you, how many of the students are missing from the class as of now?
28 students, ma'am.
20. So are
20.
we sure that they are going to come?
Yes, they will come, ma'am. Shortly. Don't on the mic, playing with the mic. Standing for the we can start. Ma'am, we can start, ma'am.
Okay. So what about the rest of the students?
They will come and join in between, ma'am.
Okay. So, in the last class, we talked about certain laws. Now, today we will learn about the mole concept. Are you familiar with this concept? I will appreciate if only one of you speaks over the mic.
Yes, ma'am. Yes, ma'am.
So you have done the basic questions on mole concepts.
Yes, ma'am. Yes, ma'am.
Okay. What is a mole? Can somebody define it for me?
The amount of substance present in compound.
See, what are you saying? Just repeat yourself. What's your name? What's your name?
Rishant, ma'am.
Ishan. Define
Rishant.
Prashant. Okay. What is the definition of a mole?
The amount of substance in a compound.
If I have an element, I cannot find its mole.
We can find mole.
Then what should be the definition of a mole?
The amount of substance. 1/12 of carbon 12 atom.
Is that not atomic mass? See, we should quickly be going through the basic definitions. Please remember, in the school as well as in the competitive exams, we have to, in competitive exams, we have to make a choice. The students who are coming late in the class are requested to be in time. Please settle down quickly. What is this such a loud discussion going on in the class? Please focus only on mole concept. Stop the discussions. You will have a break after the class for this. Okay. So can somebody define mole very specifically for me? Or for the benefit of rest of the students? See, again discussion. What are you people discussing? Please share it with me also.
Ma'am.
Yeah.
I tell. The mole is the SI unit of amount of substance, ma'am. 1 mole contains exactly 6.022 into 10 power 23 elementary entities.
And anything else?
This number is fixed numerical value of Avogadro constant.
Okay. Any more addition to this definition by any one of you?
It is a system, is a measure of number of specific element, symbol n, small n.
I agree to it, but it is a partial definition of a mole concept or a mole. Does anybody wants to add on to it? Okay, let us quickly begin. What is a mole? You might have heard it and you might have learned it, but probably you are not able to recall it as at this moment. See, whatever we do in everyday life, it has to be either counted or weighed. As of now, I need to count how many students are there in the class. The total mass of the student or total weight of the student is not going to help me out. I need to know the number of students to know what is the strength of class. Let's say your class has 40 students. Out of 40, how many are there? Right? But there are times when we need to know the mass as well as the number. Talking of the banana, I'm not too sure, but in your city, bananas might be sold in numbers like 12, 24, 1, 2, like that. But there are places where banana is sold in kgs. If you ask the vendor, he or she will tell you that it is 50 rupees kg. In your city, you might be getting it, say 50 rupees for 6 bananas. So similarly, if scientist has to carry out a chemical reaction, he also or she also needs a calculating or accounting unit, and that is called as mole. But before we move to understand what is a mole, we must recall what are the basic definitions which we will be using them while doing numericals on mole concept, or whenever we are defining a mole. So can anybody tell me relative atomic mass? Somebody, Rishan, if I am correct, told me that it was 1/12 of carbon. What was that? What is relative atomic mass? Students, it's a class 9th concept. Whatever idea, it may be incorrect, I'll still appreciate if any one of you can speak. Are you able to hear me? It's
Yes, ma'am.
so anybody, have you heard about the term atomic mass or relative atomic mass?
We couldn't recall, ma'am.
Okay. See, relative atomic mass means, or when, what is the meaning of atomic mass that we know? What is a relative atomic mass? Relative means that we are comparing the two quantities, right? If I say the student A has got 30 marks more than student B, what does this mean? Student A might have got 30 marks and other one might have got 0, isn't it? Or someone might have got 60, the other one might have got 30. That means we are talking about the relative numbers. We are not talking about the exact numbers. Making sense or not? What is the meaning of relative atomic mass? Is that clear?
Yes, ma'am.
Okay. So relative means that you are comparing two quantities. So for this, you may compare it with not only to any two, you can pick any two students. Similarly, the scientist had to make a choice. First of all, they chose hydrogen as a comparative scale. Then they moved to oxygen as a standard. Then finally, they have settled for carbon 12. Can anybody tell me the meaning of carbon 12 and carbon 14? Or first of all, have you heard about these two terms? What is
Isotope of carbon, ma'am.
so I agree, completely agree that C12 and C14 are isotopes of carbon. What is the significance of number 12 and 14 here?
Most abundant.
Then if I say, if I take isotopes of hydrogen as protium, deuterium, and tritium, for oxygen, I write O16 and O18. See, please remember, this is not written in the book, it's not your fault. But C12 means that atomic mass of this particular atom of carbon is 12. In this case, it is 14. For the benefit of all of you, I can elaborate on this. C12 means it has how many proton, electrons, and neutrons? It has got 6 protons, 6 electrons, and 6 neutrons. If I talk about C14, it has number of proton and electrons are same, but number of neutrons are different. So how many neutrons it will have? 8. So what, therefore we say it is 14. And this one, the first one is called as C12. Is it clear? How to read C12 and C14? we, in the definition of atomic mass, we will never use C14. Please pay attention. It is always C12, never C14. So what we do, we assume, we divide carbon, one atom of carbon into 12 parts. So what happens as a result of it? Every part will have one atomic mass. How do I get that? It is 1 by 12 multiplied by 12. Making sense to everyone or not?
Yes, ma'am.
Okay, so that means how do we define 1 by, we have 1 by 12 multiplied by 12. 1/12 of C12. So that's how you get 1. So we say that atomic mass of an element will be the number which tells you how many times it is heavier than 1/12 of C12. Its unit can either be AMU or U. AMU stands for atomic mass unit, and unified mass is the full form of U. While you have solved the numericals, you might have come across these. The most recent unit which is suggested by IUPAC is U, that is unified mass, right? Should I move ahead?
Yes, ma'am.
And next time I believe that I'll be getting the correct answer from the entire class, that atomic mass is the number which tells us how many times an element or an atom is heavier than 1/12 of C12, right? So that for practical purposes, we may ignore that 1.008, right? 0.008 can be neglected from it. We can always delete it while we are solving the numerical, because there is no point in calculating them to such a high number of decimal places. So instead of 15.99, we should be having 16, right? So for all practical purposes or for solving a numerical, we either have 1 or we use it at 16 for oxygen. Now, since we have understood what is relative atomic mass, we can always define what is relative molecular mass. So can anybody give me an example where we will be using the term relative molecular mass? Name of any compound? Please come one up, any one of you. Since I am not getting any answer, can I be part of a discussion? Or
Yes.
where is the confusion?
We can continue.
Huh? I didn't understand. Please repeat.
We can continue.
I still didn't get it.
We can continue, ma'am.
Okay. See, atomic mass is associated with element, or it is associated with atom, more precisely, right? If I have oxygen atom, it will have atomic mass. So what we can say, atom of an element will have atomic mass, but molecule will have molecular mass. O2 is a molecule, CO2 is a molecule, CH4 is a molecule, MgCl2 is a molecule. All of them are going to have molecular mass. right?
ma'am.
Whenever we write the term gram or G after the value of atomic mass, it becomes gram atomic mass. Is there still any problem there in the class?
Voice is little low, ma'am.
Why is there little?
It is low, ma'am. We cannot, it's high.
I still cannot understand what do you want to say.
You are not audible, ma'am.
I'm not audible.
Loud,
Okay, now am I audible now?
yes, ma'am. No, okay, ma'am.
Okay. So from which point do I need to repeat again?
Atomic mass, ma'am.
Atomic mass. Okay. See, atomic mass. What is atomic mass?
Ma'am,
Yeah,
last side.
this one,
No, ma'am. Next slide.
this one.
Next slide. Yes, ma'am.
Okay. Whenever you put gram after the atomic mass, it is referred as gram atomic mass. We understand that atomic mass of nitrogen is 14. If I write G after it, it becomes gram atomic mass of nitrogen. Right? Is it clear?
Yes, ma'am.
Okay. Now moving to what is molecular mass. For that, we must understand what is a molecule. Molecule, as we know, can be of two types, right? One can be the molecule of element and the other one is molecule of compound. Now, example of the first category, molecule of element is O2, N2, H2. And for the molecule of compound, we have, as I have written, it is CO2, CH4, NH3, HCl. These are the example of molecule of compound. So what is molecular mass? The sum of atomic masses of all the constituents. So for oxygen, what it will be? It will be 16 plus 16, making it as 32. For methane, it will be, what should I write? Carbon is 12, hydrogen will be 1 into 4. That will be 16.
Great.
Okay. So rest of them you can always find out, or you must have done it in your classrooms. Now, can somebody tell me the molecular mass of nitric acid? For that, do you know the formula of nitric acid?
17.
Nitric acid 17, how it can be? What is the formula of nitric acid? See, I will appreciate if now onwards you people start knowing the formulas of compounds.
63.
63. Okay, how did you get that?
Ma'am,
Yeah,
N is equal to 14, ma'am.
yeah.
O3 is equal to 16 into 3 is equal to 48, ma'am.
Okay,
Plus
correct.
1 is equal to.
Okay, I got it. That
Yes,
see, I was
thank you,
just
ma'am.
thinking, how did you get it? I just, for the benefit of others, the formula of nitric acid is HNO3. If you know it, then it will be very easy for you. It will be 1 plus 14 plus 3 into 16. You solve it and you get it 63,
Yes, ma'am.
right? And similarly, I'll appreciate I'm giving you a list of certain compounds which are very frequently asked.
Okay, ma'am.
If you remember those, that will be very helpful because this is the first step in solving the numericals of stoichiometry. So HNO3 is one of them. Then we have H2SO4, water,
Yes, ma'am.
calcium. I'm not asking you to give me the answer. I'm giving you the list for which I expect you to remember them.
Okay, ma'am.
Ammonia, methane, carbon dioxide, carbon monoxide, hydrogen peroxide. They are very frequently asked in various exams as a part of a 3-mark question,
Ma'am,
right? Yeah,
ma'am, I have a doubt, ma'am.
yeah.
Ma'am, how carbon monoxide is found? I have a doubt in that, ma'am.
How carbon monoxide is formed.
Yes, ma'am.
Want to know about the bonding or what?
I've found in some situations, so many, ma'am. Carbon dioxide should.
See,
How?
you have heard about or you have read about the law of multiple proportion.
Yes, ma'am.
Carbon reacts with oxygen under the controlled oxygen condition. That is, when oxygen supply is low. In the low supply of oxygen, it forms carbon monoxide. And when oxygen is in excess,
Yes, ma'am.
then it forms carbon dioxide.
Okay, ma'am.
Okay, and if you want to know the structure, I really did not get your question. If you want to know how it is formed means what is its structure, then probably when we will be dealing with the chemical bonding, first of all, carbon and oxygen, they form a double bond and then they form a coordinate bond. That's
Okay,
all.
ma'am. Yes,
Right?
ma'am. Understood, ma'am.
Okay,
Thank you, ma'am.
welcome. Similarly, relative molecular mass, if you that you can understand now, if you have understood relative atomic mass is applicable only for atoms, and molecular mass is applicable to compounds. Right? So somebody started with the class with the compound only. So please understand, see, atomic number, atomic mass, molecular mass, they are associated with atomic. What means they are associated with atom? Molecular means they are associated with molecular mass. For molecular means it is associated with molecule. In the beginning of the class, I was trying to get this terminology out of you. What is a molar volume? Everybody told me that molecule, mole is related only to mass. We will just see it is related to number of particles as well as volume also. Before that, we must understand what is atomicity, because in some of the questions, they ask you to find the atomicity. Atomicity means how many atoms are present of different types are found in that particular element, right? Sorry, in the compound. Do you know this? Have you heard about ozone? Ozone depletion, depletion.
O3.
Huh? O3. Okay. Oxygen is O2. Ozone is O3. How are they related to each other? There is a specific term to it. Any idea? And if you are not able to get that answer, the clue is how is diamond and graphite attached related to each other? Diamond and graphite.
Ma'am,
Yeah.
O2 plus O equal to O3.
No, I'm not talking about the reaction. I'm asking them, see, how they are related. You don't need to change their existence. You just need to find a relationship between them. In class 10th, you studied about diamond and graphite. What are they collectively known as? They are, what do we fill in this gap? They are,
Carbon compounds, ma'am.
no, They are, see, they are not compounds, first of all.
Allotropes, ma'am.
H2 is an element or a compound? H2 is a compound and CO2 is also a compound. But this compound has only one type of atom. It has got two types of atom. So carbon is an element. Carbon is never a compound. The element present in H2 is H, right? It exists as H2 molecule. Carbon is an element. Diamond and graphite. Have you not done this term in class 10th? Allotropes. Have you heard about this term or not?
Yes, ma'am.
What was that? We said it is the existence of same element in different forms in same physical state. See, it is important for you to understand that as the syllabus will continue, we will be having a cross-chapter questions. Cross-chapter means one part coming from one particular chapter and another coming from another chapter. So this is one of such questions which I have put up here, so that you just keep an eye that you have to recall your class 10th also. So diamond and graphite, if I am correct, then we did that in class 10th, diamond has a rigid structure, whereas graphite has a slippery structure. But at the end of the day, both of them are made up of carbon atoms, isn't it? Please say yes or no. Please pick up the mic and speak, class.
Ma'am.
Sim, have you understood what is allotropes?
Yes, ma'am.
Okay, so can we say oxygen and ozone are allotropes? Oxygen and ozone both are allotropes of oxygen atom or oxygen
Yes,
element.
ma'am. It's a allotrope.
You don't know. Oxygen element, now I'm explaining it again. Oxygen element, when two atoms combine, it forms oxygen, which is lifeline of us, right? But when three atoms of oxygen combine, they form ozone molecule. Is it clear?
Yes, ma'am.
Okay.
Correct.
So oxygen and ozone are related as allotropes of each other. On the basis of number of atoms present in the molecule, they can be monoatomic, diatomic, or polyatomic. Example of monoatomic are usually the inert gases. For diatomic molecules, you can see that whichever is having two atoms, O2, Cl2, N2, they are called as diatomic. Then polyatomic, the important examples are phosphorus and sulfur. Many a times, a question is asked either on phosphorus or on sulfur because they have atomicity or very high atomicity as 4 and 8. Is it clear to everyone?
Yes, ma'am.
Okay. Now these are the terminologies. This we have done. Now let me explain to you what is a mole. We say that mole can be related to many things. Please pay attention so that you are able to solve the questions later on. 1 mole will be equal to, if I talk about mass, it will be atomic mass or molecular mass in grams. That we have explained both the terms, what is atomic mass and what is molecular mass. Same thing is equal to 22.4 liters at STP. STP stands for standard temperature and pressure. And it is equal to 6.022 into 10 to the power 23, which can be atoms, which can be molecules, which can be ions, which can be even electrons. Usually, in any subject, we see equities between only two things. Here, 1 mole will have all three equities. By this, we mean to say that if I take sodium as an example, I will read it as atomic mass of sodium is 23. So that means 23 gram of sodium will be equal to 1 mole. Then I will say its volume, if measured at STP, will be 22.4 liters. And if I count the number of particles, in this case it is atoms, it will have 6.022 into 10 to the power 23 atoms of sodium. Is it clear to all of you or not?
Yes, ma'am.
Was it clear earlier also?
Yes, ma'am.
But then why was nobody able to answer me?
Yes, ma'am.
What's yes, ma'am? Okay. What about STP? What do you understand by STP?
Standard temperature pressure.
Okay, that I have told. I mean, what is the value of standard temperature? And pressure.
2.4 liter.
Huh? I didn't get you. Please repeat.
22.4 liter.
See, STP, temperature and pressure, 22.4 liter is a volume. I'm asking for what is the value of temperature in STP? What is the value of pressure? STP, what is the temperature? What is the pressure?
6.022 into 10 power 23.
Come on, 6.02 into 10 to the power 23 is entity's number. Temperature has to be in degree centigrade or degree Fahrenheit or Celsius. So it is 30 degree, 40 degree, 50 degree watt. Pressure is 1 Pascal, 2 Pascal watt. If you have to solve a numerical, if you have to find the 1 mole of a substance, what you will do? What temperature should you keep and what pressure?
100 degree. 100 degrees Celsius.
No. See, STP is a unit or which is used by so that the comparison is fair. Whenever you are asked to give an exam, the condition to the entire batch or to the classroom is given the same. That is, they are given, let's say 30 minutes for solving 20 multiple choice questions. And everyone is measured on the same marking pattern. Similarly, if I have to compare two different solids, liquids or gases, or whatever element or a compound, I need to have a standard temperature and standard pressure. So the value of standard temperature and pressure is written here. It is 0 degrees Celsius, right? And the value of pressure is 1 Pascal. Or not 1 Pascal, 1 atmosphere. Is it clear? If somebody tells you to define STP It is the temperature will be 0 degrees Celsius and pressure will be 1 atmosphere.
Okay, ma'am.
For calculation, we know that 0 degrees centigrade is equal to 273 Kelvin for conversion. But if somebody wants me to define it, I will always be saying 1 atmosphere and 0 degrees centigrade. In numerical, I may be using 273 Kelvin, right? But 0 degrees centigrade is quite impractical thing to do. In a laboratory condition, 0 degrees centigrade is practically very difficult. You can achieve it like your refrigerator, or we commonly call it as fridge. The temperature is below 0, right? So the ice cream or the ice remains in the solid state. But you really do not know what is the temperature. Is it -1, -2, -3 what? So 0 degree centigrade is still, it can be achieved there, but not maintained. So that, or that is the reason scientists, whenever they have to compare two substances, they devise another comparison unit. We call it as NTP, or which stands for normal temperature and pressure. Sometimes the numericals are related to NTP also. See, as I understand that you will be appearing for various competitive exams also, there these two terms, STP and NTP, become very handy. We have one chapter, states of matter, there we will be using them. Thermodynamics, indirectly, we will be using those 3 or 2 terms. So at NTP, 20 degrees centigrade is a pretty normal temperature to be achieved and maintained. So if I cannot achieve STP in the laboratory, I prefer to work for all gases, comparing them at 20 degrees centigrade and 1 atmospheric pressure. Clear? Please say yes or no. Please speak over my mic. The voice is very muffled.
Yes, ma'am.
Okay. This
Ma'am,
is just
you
an
zoom on that slide, NTP.
I didn't get you. NTP.
Zoom, ma'am. Can you zoom, ma'am?
Can I zoom that? Okay. Can you see it now better?
Okay, ma'am.
Okay. This is just a fun fact. You can also do it in your school, that we say that 23rd of October, since the value of mole constant is 6.022 or 6.023 into 10 to the power 23, the scientists celebrate 23rd October as a mole day, starting from 6:02 a.m. to 6:02 p.m. Right? You can also do it in your school, and then what you can do, you can divide your time, you can divide yourself among in the groups and solve a lot of question on mole concept. So let's start doing practice on bit difficult question, although this can be done orally if I know the molecular mass of calcium carbonate. Quickly find the number of moles in 40 grams of calcium carbonate. If division is taking time, just give me the fractional answer.
.4, sir. Chief Foreman.
I didn't hear you properly. Can you just be?
0.4 moles.
0.4 moles. Rest of the class? See, the only thing is, if you wish, you can add that calcium carbonate also to that list. Atomic mass of calcium is 40. That of carbon is 12. And oxygen is 16 into 3, making it as 100. Right? Has the entire class solved the question or not?
Yes, ma'am.
Got the answer? After that, it becomes, if you know that 100 is the molecular mass of calcium carbonate, then it becomes pretty simple that 100 grams will be equal to 1 mole. Then you apply the unitary method. That is 40 grams will be equal to what? That you can simply solve. That's what I said, that I'm not interested in the entire answer, but the simple calculation part of it. Now, this one can be done orally.
Ma'am,
Yeah,
2.5 moles, ma'am.
I didn't hear you properly.
For previous question, ma'am, 2.5 moles is the answer.
What is the answer?
1 minute.
See, this should be the pretty straightforward question. 100 grams is equal to 1 mole. Then 1 gram will be equal to 1 by 100 moles. And therefore, 40 grams will be equal to 1 by 100 into 40. That is 40 by 100 or 0.4. Is it clear to everyone now or not? Please say yes or no. I will
Yes, ma'am.
appreciate. It's clear. See, basically, once you understand out of the 4 equities of mole concept, which 2 you have to pick up. After that, it is just unitary method. I believe you understand what is unitary method. I'm not getting any response from the class. What has happened?
Yes, ma'am.
Okay. Now
Okay.
the challenge is you have to solve this question orally. Don't use your pen and paper. Tell me the answer orally. And more importantly, please, instead of discussing among yourselves, you can always ask me the question.
Ma'am, 22 grams.
22 grams. Everybody got it or not?
Yes, ma'am, got it.
Okay, that was the reason sometimes I give you the easy question also. Molecular mass of carbon dioxide is 44. 44 grams is equal to 1 mole. So half, that is 22 grams, will be equal to 0.5 moles, right? Okay. Let's do this question. Can you read the question? The volume occupied by 8 grams of nitrogen at STP.
Calculate the volume occupied by 8 grams of nitrogen at
Yeah. STP. If you need the help in atomic mass of nitrogen, that was 14. Yeah.
Ma'am, in our screen, the path is big, ma'am, so we cannot see after act, ma'am. 8 gram of nitrogen after that, ma'am.
Please repeat. What are you saying? I didn't hear you
Ma'am.
properly.
After act, it's not visible, ma'am, in our screen.
I'm saying calculate the volume of. Now,
Okay.
can you see it?
Yes, ma'am, now we can see it, ma'am.
Okay.
Okay, ma'am.
Okay. Please solve the question. Anybody who has got the answer? What is the progress on the question? Students, should I discuss the answer?
Yes, ma'am.
You haven't got any answer to it? See, the only trick in this question is that what should we take nitrogen as N or N2? That is the only question, only thing here. What would you choose, N or N2?
N2, ma'am.
Why N2 and why not N? See, I'll give you the reason because instead of solving a query or question is also important, but knowing the reason will settle it for all the elements. See, we have to choose. If I have written nitrogen, we must know what is its state. the stable state at room temperature. At room temperature, nitrogen exists at N2. So when you are solving a question on a mole concept, consider the physical state for writing such thing. Similarly, if you have to solve it for phosphorus, you should have considered phosphorus as P4. If you were solving it for carbon, you must take it as C only. Solving it for sodium, it should be Na. Right? Is it clear, or you're just solving the problem? Can somebody apprise me what you people are doing there?
We are discussing and doing, ma'am.
It was, I believe, individual task. Instead of discussing, I'll just tell you, I will show you the answer and we can discuss it, that the formula of nitrogen is N2, right? So after that, I think the life becomes easier. I have to, from the mole concept, I just have to pick that 28 grams. The choice which was difficult was whether I should take 14 grams or 28 grams. So it is clear, since nitrogen is existing as N2. So we should be taking 28 grams. And what I should be equating it, 28 grams of N2 is equal to 22.4 liters. Therefore, again, I say, whosoever doesn't understand the unitary method, I believe most of you or all of you must be. So therefore, 1 gram of nitrogen will be 22.4 upon 28. And I think I have asked for 8 grams. So 8 grams will be equal to multiplied by 8. Is it clear to everyone now?
Yes, ma'am.
Okay. So can somebody briefly tell me what was the reason that you were not able to come to the answer? See, if we speak out the issues, I can probably help you in solving the questions of the different type.
We got confused in volume.
Okay. See, that is why when I started teaching you, I asked, do you... See, when I was here, I was telling you that out of, again, this slide is important. Read the question carefully is the first instruction, then wisely choose. What are the two entities? What are the two things which you must equate? Because, and that is the reason I wrote the example of sodium also. There is no rocket science in solving a mole concept question, except that you have to choose two entities which you must equate. So I'll go back to the question and repeat what with both the examples we have done. 40 grams of calcium carbonate and moles. So what I should choose here? I should choose 1 mole because one of the entities written here is mole. And 40 gram. The gram entity in the mole concept was molecular mass in grams. So the moment I know this, I can solve that molecular mass. 100 grams is equal to 1 mole. So 40 grams will be what? Now coming to the next question. 0.5 moles of CO2. Again, mass and mole. 1 mole is equal to molecular mass. You use those two equities and solve it. Similarly, talking about this, you were given grams and you were asked the volume. Volume always means 22.4 liters at STP. Mass means you are referring to molecular mass. So again, it was pretty simple. If you follow this logic, you will always be able to solve the question easily. Now quickly do this question. Again, it should be the oral one. If you know the molecular mass of water. I think all three options are visible to you.
Ma'am.
Yeah.
Option B, ma'am.
How did you reach to option B? Do rest of the students agree with the answer? Yeah.
He told wrongly, ma'am. He confused, ma'am. A is the correct answer, ma'am.
I didn't get you. Please say it again.
The option, ma'am, option A is correct answer, ma'am. Option A is correct, ma'am.
How it can be the correct answer? See, what is the
Ma'am.
molecular mass of water?
Ma'am, option B only.
See, by putting this question, I just wanted to tell you at times there is no need to calculate. See, we know molecular mass of water is 18 grams. I believe everybody understands it now. This should be 1 into 2 plus 16, making it as 18, right? 18 grams will be equal to 6.023 into 10 to the power 23. So that means, and I have asked for 0.018.
Excuse me, ma'am.
Yeah,
Ma'am, time up, ma'am. We must.
yeah, I'm just leaving you for in a minute. When it, okay, I'll just leave you in a minute.
Okay.
So this one is obviously incorrect answer. Since we are put, then the correct answer cannot be more than 23 because we are reducing the mass. So the obviously correct answer is this one. This is also incorrect, right? The purpose of putting this question here was that at times, if you remember the molecular formula, it's very easy to solve the MCQ question, right? So I'll see you in the next class. I'll appreciate if you can revise the mole concept, do more questions on it. We'll pick up stoichiochemistry in the next class, right? Okay, thank you. Have a good day.
Thank you, ma'am.
Welcome.